3 volcanoes are active across the Pacific Ring of Fire right now. One has been erupting for 135 days. One has not erupted since 1972. The other never stopped. As of Monday, May 18th, 2026, Mayon Volcano in the Philippines is on its 135th consecutive day of effusive eruption. PHIVOLCS, the Philippine Institute of Volcanology and Seismology, has held Alert Level 3 since January 6th. Southeast of Mayon, in the central Bismarck Sea off Papua New Guinea, a submarine volcano is erupting for the first time in 54 years. The eruption began on May 8th. Further west, in the Indonesian archipelago, 2 more volcanoes are pushing ash into the same airspace. Ibu, on Halmahera Island, has been erupting continuously since April 2008. Semeru, on Java, sits at Alert Level 3 with more than 60 explosions per day. Dukono remains active in the background. But here is the detail that tells the real story. International coverage will register each of these as separate news items. Each headline matches the bulletin. None of them connect. What is almost nowhere reported is that the same Darwin VAAC office is typing advisories for all 3, and the same Himawari 9 satellite is capturing them in the same scan. The Pacific Ring of Fire is not 3 separate stories this week. It is one tectonic system producing 3 different kinds of crisis at once. The question is what it means when one tectonic belt produces 3 simultaneous, distinct eruption stories, and the only thing connecting them is the geography they all share. This is where the story starts, because it never ended. Mayon Volcano stands 2,463 meters above the Albay Gulf in southern Luzon. The earlier acute phase, the explosive bursts, the wide area ashfall, has been covered in prior bulletins. The current phase is different. The eruption has settled into sustained, effusive activity. Lava continues to feed 3 established gully systems, 3.8 kilometers down the Basud on the east, 3.2 kilometers down the Bonga on the southeast, 1.6 kilometers down the Mi-isi on the southwest. They thicken, they consolidate, and then they collapse. This is the danger that has replaced the explosive risk. Pyroclastic density currents, locally called uson, are no longer generated by explosions at the summit. They are generated by collapses of the lava flows themselves. Each flow unit is a body of hot rock with a solidified outer crust and an extremely hot interior. When a flow margin destabilizes, the unit fragments and avalanches downslope as a hot, dense, fast-moving cloud of rock and gas. Sulfur dioxide averaged 889 tons per day in the most recent report, below the March peak of 7,633 tons per day. Heavy rain can mobilize new PDC deposits into hot lahars on the downslope channels. This is the volcano that nobody could see. On May 8, 2026, the Department of Mineral Policy and Geohazards Management of Papua New Guinea recorded a swarm of 6 earthquakes at coordinates 3 degrees 02 minutes south, 147 degrees 07 minutes east, approximately 118 kilometers southeast of Manus Island. Seismic precursors had been recorded on March 31 and April 25. Then a submarine eruption began. A plume of shallow sediment and discolored water, approximately 9 by 11 kilometers, appeared on the sea surface. Within 2 days, satellite imagery resolved a steam plume rising 3,000 meters above the eruption center. The volcano has no name. Over 4,000 feet underwater. The eruption happens in the dark, in seawater, at depth. The only evidence is what reaches the surface. Discolored water, steam, gas, and eventually ash punching through. The Darwin Volcanic Ash Advisory Center issued its first advisory on May 11th and has updated it more than 20 times since. The peak came on May 15th, ash to flight level 280, approximately 8,500 meters above sea level. By May 17th, the latest advisory described a plume at flight level 120, 3,700 meters moving northwest. The volcano sits at the junction of two segments along the northern margin of the South Bismarck Plate, a transform fault to the east, oblique active seafloor spreading to the west. The eruption is happening where two different kinds of plate motion meet. The only confirmed prior eruption at this site in 10,000 years was January 1972, detected via underwater acoustic signals on hydrophones at Wake Island and Midway Island, thousands of kilometers away. This is where volcanic activity is routine and dangerous. Indonesia sits at the convergence of four major tectonic plates: the Indo-Australian, Eurasian, Pacific, and Philippine sea plates. The country hosts approximately 130 active volcanoes, more than any other nation. Ibu Volcano stands 1,325 meters above sea level on Halmahera Island, North Maluku. On May 12, the Darwin VAAC issued Advisory 2026-535, documenting ash to flight level 070, 2,100 meters moving northwest. Ground reports describe discrete intermittent emissions continuing through May 18. The pattern is familiar: small bursts, frequent, low altitude, persistent. Semeru Volcano stands 3,657 meters above sea level on Java, the largest volcano on the island. Indonesia's Center for Volcanology and Geological Hazard Mitigation has held the alert level at 3, standby on a 4-level scale. On May 8, 68 explosions in a single day. On May 12, 61. On May 15, 53, with pyroclastic density current signals detected. The latest VAAC advisory, May 17, documented ash at flight level 150, 4,600 meters, moving east. Dukono has appeared in prior channel coverage following a tragedy involving hikers in restricted zone activity. It remains active. It remains dangerous to those who enter areas the alert systems have closed off. To understand what kind of week this is, look at the monitoring systems. The volcanoes do not coordinate. Mayon, the central Bismarck Sea submarine source, Ibu, Semeru, 4 separate systems, 4 magma chambers, 4 stress fields, no shared trigger, no causal link. The monitoring infrastructure is different. It is shared. The Darwin Volcanic Ash Advisory Center is one of 9 VAACs worldwide under the International Airways Volcano Watch, responsible for Indonesia, Papua New Guinea, and the southern Philippines. The same office is issuing advisories for all 4 systems, often within the same hour. The Himawari 9 satellite, geostationary, operated by the Japan Meteorological Agency, captures all 4 eruption sites every 10 minutes. The same satellite frame can hold Mayon's plume, the Bismarck Sea steam column, and Semeru's ash drift. The Smithsonian Institution's Global Volcanism Program updates a daily activity report listing all of them alongside dozens of other restless systems. Aviation routes are continuously adjusted on the advisories. The story this week is that one tectonic belt, one monitoring office, one satellite, and one global database are tracking 3 kinds of volcanic crisis at once. And all of them are still going. The monitoring systems are still watching. The Ring of Fire is still doing what it does. The question is not whether the Pacific Ring of Fire is active. It is. Approximately 90% of the world's earthquakes occur within it. The question is not whether these 3 eruptions are connected. They are not. Mayon's magma comes from one subduction zone. The Bismarck Sea comes from a transform fault spreading center junction. Ibu and Semeru come from a third. 3 different sources. 3 different mechanisms. 3 different consequences. The question is what it means when one tectonic belt produces 3 simultaneous volcanic stories. A 135-day land eruption, a 54-year silent submarine source, and persistent aviation hazard activity from one of the most volcanically restless countries on Earth, and the only common factor is the Ring of Fire itself. The Ring of Fire is the system. As of May 18, 2026, Mayon is on day 135. The Bismarck Sea submarine source is on day 10 after a 54-year silence. Ibu and Semeru continue pushing ash to flight levels 7 and 15. The Ring of Fire is not quiet tonight. If this story is worth telling, subscribe. We cover more of these every week.